We're constantly surrounded by data, charts, graphs, percentages, all promising to give us a clear picture of the world. But what if that picture is actually an illusion? Today, we're going to dive into the data illusion and look at how the numbers you see every single day can be designed to trick your brain. Let's get right into it.
So picture this. It's 1995. A UK health committee makes a huge announcement. A new contraceptive pill, they say, doubles the risk of a dangerous blood clot. The headline was absolutely terrifying. And the statistic, it was technically true. This sparked a nationwide panic. Thousands of women stopped taking their medication, which led to a huge surge in unwanted pregnancies and abortions. Now, this wasn't a lie, but it was a catastrophic failure of communication. And it all came down to one single missing piece of context, a little trick that plays on how our brains perceive numbers.
And this really gets to the heart of the problem, right? This quote from the classic book, How to Lie with Statistics, just nails it. Data feels objective. A graph doesn't use loaded words, it just presents itself as pure, unvarnished fact. And that illusion of objectivity is exactly what makes these data tricks so powerful. They sneak right past our critical defenses because they're disguised as science. Okay, so let's start with the most common culprit out there, the way we actually see data. Visuals can be manipulated in some really subtle ways that completely change the story they're trying to tell. Take a look at this graph. At a quick glance, it looks like there's a huge difference between these two bars, right? I mean, your eyes aren't playing tricks on you. That's what it's designed to make you think. This is a classic move called a truncated graph. If you look closely at the vertical line, the y-axis, you'll see it doesn't start at 0. By chopping off the bottom, whoever made this has essentially zoomed way in on a tiny part of the data, making a small difference look like a massive chasm. Okay, now look at this. This is the exact same data, but with one crucial change. The y-axis now starts at 0, where it's supposed to. And poof! Suddenly, that dramatic difference practically disappears. The data hasn't changed at all, but the story is completely transformed. It went from looking like a crisis to a total non-event, just by fixing the scale. See, visual tricks like that are pretty easy to spot once you know what to look for. But the numerical traps, well, they're often a lot more subtle, and they prey on the way our brains are wired to think about risk. A few years ago, this number was everywhere. Headlines were screaming that eating processed meat, like having a bacon sandwich every day, was linked to an 18% increase in your risk of getting bowel cancer. I mean, that sounds terrifying, doesn't it? An 18% jump in your cancer risk. That seems like a massive deal. But this brings us to the single most important question you can ever ask when you see a statistic like this one. An 18% increase of what? This is what's known as a relative risk, and when it's presented all by itself, it's virtually meaningless. It's missing the most crucial piece of information. What was the risk to begin with? So let's add that missing context back in. The baseline risk of getting bowel cancer in your lifetime is about 6 out of 100 people. You see that on the left. Now, that scary 18% increase, that's 18% of that 6%, which brings the total risk up to about 7 out of 100 people. So what the headline really meant was that if 100 people ate an extra bacon sandwich every single day, maybe one additional person might get bowel cancer. The jump in what we call absolute risk is just 1 percentage point. It's still a risk for sure, but it sounds a lot less scary than 18%, doesn't it? So why are these tricks so incredibly effective? Well, it's not because we're bad at math. The truth is, our intuition has a fundamental glitch when it comes to dealing with probability. A researcher named Gerd Gigerenzer calls this statistical innumeracy. But he argues that the problem isn't some deficiency in our minds. It's actually in how information is presented to us. We're not dumb. The data is just framed in a way that our natural cognitive wiring finds really, really confusing. And there is no better example of this than the most famous brain teaser in all of statistics. Okay, imagine you're on a game show. There's a brand new car behind one of these 3 doors. You pick a door, let's say door A. Then the host, who knows where the car is, opens another door, door B, and reveals a goat. He then turns to you and asks, do you want to stick with your first choice, door A, or do you want to switch to the last door, door C? What do you do? I know, most people's intuition just screams that it's a 50-50 shot now, but that intuition is wrong. Here's why you should always, always switch. When you made your very first pick, you had a 1 in 3 chance of being right and a 2 in 3 chance of being wrong. That means the other 2 doors together had a 2/3 probability of hiding the car. Now, when the host opens one of those doors and shows you a goat, he's not changing the past. Your initial door still only has that 1/3 chance,
But now, the entire 2/3 chance that was spread across those other two doors gets concentrated on that single remaining door. So by switching, you're actually betting on that much better 2/3 chance. So, knowing all this, how can we fight back, right? How can we arm ourselves against all these data illusions? Well, luckily, there's a pretty simple toolkit we can all use to bring a little clarity to the confusion. Gigerenzer's research gives us a really simple guide. Instead of getting all tangled up in confusing percentages and relative risks, the solution is just to reframe the information. The key is to translate those abstract percentages into concrete numbers that our brains can actually picture, just like we did with the bacon example. The first, and honestly, the most powerful tool is to always convert probabilities into what are called natural frequencies. So don't think in terms of a 0.7% chance. Instead, mentally translate that to something like, out of 1,000 people, 7 will experience this. It's a small mental shift, but it makes the abstract feel tangible. It grounds the numbers in a real-world group of people, which our brains find way easier to process. And for any graph you come across, just keep this quick checklist in your back pocket. First, always check that y-axis. Does it start at 0? Second, be really wary of 3D effects. They distort perspective and make things in the front look way bigger than they are. Third, just make sure the numbers on the scale are consistent. And finally, if they're using little pictures, check that they're scaled by height, not by area, which can massively exaggerate the differences. You know, when it all comes down to it, the most important thing to take away from this is that data never, ever speaks for itself. It's always presented by someone, and that presentation is a form of storytelling. Your job as a critical consumer of information isn't just to look at the numbers, but to ask yourself, who is telling the story, and what story are they trying to tell me? So the next time you see a chart in the news or a statistic in an ad, just pause for a second. Use your new toolkit. Ask those hard questions, because in a world that's drowning in data, understanding the difference between information and illusion is one of the most vital skills you can possibly have. The real question is, what story will you uncover? Thanks for tuning in.